Hey everybody, it's Rothbard's Disciple here, once again with another video talking about Bitcoin. Today we're going to be talking about transaction ordering in Bitcoin and why it's sort of a big deal. I've wanted to make a video on this for a very long time, but unfortunately there's just not that great of information surrounding this subject. So because of that, I'm sure there will be mistakes here, but I know there have been other videos released on transaction ordering that where the creator of the video has less of an understanding of this topic than I do, but I just want to give my 2 cents on it. Like I said, there's not that much information regarding this, which is sort of weird since it was the main reason for the Bitcoin Cash, Bitcoin SV split, as well as DSV or whatever. And so you would have figured there'd be more information on it, but there just isn't. So I'm just going to tell you guys what I think about transaction ordering and the issues that I see with um, each form of transaction ordering, and I also will tell you that I don't really necessarily have a preference or my preference isn't really that great. I prefer the natural transaction ordering that Daniel Connolly has suggested, but I'm honestly not sure. So for transaction ordering, as far as it goes, there's three main types of transaction ordering. There's the topological transaction ordering, which is Bitcoin's original transaction ordering, where it puts parents before children, which basically just says that if one transaction within a block, like let's say I have an address and I spend some coins and send them somewhere, and then what if those coins are sent somewhere else before a new block is found? The first transaction is the parent, and the transactions that are dependent upon the first transaction are the children. And so with topological transaction ordering, it says the parents go first and then it's the children. Okay, and so this could maybe have some use cases for ensuring that there's no double spends, because you get to see all the parents first, and then all the children have to be dependent upon one of those parents, or whatever. But next one is canonical transaction ordering, or CTOR. This is Bitcoin Cash's new transaction ordering format. It's basically just alphanumeric or ABC order. So it basically just whenever you get a transaction, you already know the order it goes in the block in, because it's already predetermined. The order is always predetermined. You don't know which transactions there are um, that are going to be in the block, but given any set of transactions, each miner will have the exact same order. Then the final ordering format type is the natural transaction ordering that Daniel Connolly has been suggesting. And the natural transaction order is just no order requirements. You just order transactions in the way that they come to you. So if a miner received transaction A first, that would be the first transaction in their block. If it received transaction, C next, then it would go AC, whatever, whatever. It's just the order that they're received. And one way you can think about this that a lot of the developers have been talking about recently, um, if you want to try and visualize what ordering means, it's like, let's assume you throw down a bunch of cards on the ground. Transaction ordering is how you organize the playing cards for pickup. So with topological transaction ordering, there's no real way to I guess put topological transaction ordering into this, because there's no parent and children playing cards. But if you're doing something like canonical transaction ordering, you would pick up the cards and put them back in order. Okay, so you would order them by suit and by number or whatever. And then with the natural transaction ordering that Daniel Connolly has been talking about, you would just pick up the cards whatever way is fastest for you. Okay, and so obviously, as you can see, like if you're not doing any ordering, the picking up of the cards is pretty simple to do. Um, and organizing those cards takes time. But the whole point of organizing the cards is so that when you find a block, because you would be picking up cards until you found a block. If you were a miner, those cards would just be transactions, but you're picking up these transactions till you find a block, and then you have to tell the other miners what block you have. Well, if everyone is picking up the cards in a specified order, according to CTOR, then once you find a block and you show everybody your hand, they're already basically going to know the order of your transactions, because they've all got the same transactions. There's going to be a couple cards different, because like the last second or couple of seconds. Each miner is going to have different transactions that they've processed. So there's a little bit of a difference in CTOR, but if you're doing it just randomly picking up cards when you send those cards to somebody else, if you're picking them up basically, not necessarily randomly, because if you're doing it in the natural transaction order, you pick up the cards at the speed that they are thrown down on the floor, so your transaction order is going to be similar to the other miners, but it's not going to be basically the exact same. Okay, so um, one of the things here, an additional point beyond just that CTOR is better for propagation and NTOR is better for just putting as many transactions in a block as you can, is that without the natural order of transactions, um, there's also the possibility that certain apps are negatively affected. Now, none of these apps exist. One of the apps that might be negatively affected, and this is the reason why ordering's been sort of important to me, and I'm more on the natural transaction ordering side, is that the one type of app that could be negatively affected is the copyleft um, hash token apps that I just released a video on. Those ones, the order can be important because it could determine who is the actual creator of certain digital content, and we'll get to that in just a little bit. But first, let's talk about why did Bitcoin Cash choose CTOR. So again, block propagation with the unknown transaction order can be very problematic, and I believe the main reason for this, and again, there's no real um, information out there detailing the specific problems here, so I just had to sort of think about it on my own and come up with this on my own. But if you're looking at a Merkle tree, and again, all the transactions in Bitcoin, they're all put into a Merkle tree. Um, the way the Merkle tree works is you hash the transactions and then take the hashes of the transactions and hash those together in pairs of two until you're left with one final root. And if you change any of the transactions, it changes the entire tree. Okay, so if you look at it, this Merkle tree that we have here, it's got transactions A through P. So the issue here is that if you change transaction A, then the hash of A changes, which changes the hash of A and B, which changes the hash of A, B, C, D, the hash of A, B, C, D, E, F, G, and then the final root hash. Okay, so any one of these transactions on the bottom, if they are changed, it changes all of the hashes above them. Okay, and so then the issue that you run into is if you're doing just a natural transaction order, the problem is that miners are going to receive each transaction at a similar speed, but since miners are located and their nodes are located at different spots in the world, the transactions, they're going to be different. The order is going to be different even though the transactions are going to be in similar spots. So instead of having hash A first, or you might have hash B first, and one miner will have hash A first, and then another miner might have hash B first, and then one miner might have hash O as the final hash in their Merkle tree, and then another miner will have hash P. There's nothing really that you can do to stop this. Throughout the entirety of the block's creation, the transactions are going to be ordered a bit differently, and so by changing the order of the transactions, the entire Merkle tree is basically going to be different. None of this is going to be even close to the same for miners using a natural transaction order. Okay, and so the whole point about using CTOR when the order is alphanumeric is since you already know the order that the other miner is going to get their transactions in, the only differences in the Merkle tree are when you add new transactions into the tree. Okay, so or in the new transactions that are going to be added and that are going to be different for miners, it's only the last second of transaction. So when that miner finds a block and publish or broadcasts their block to the network, the other miners are still working on their own block and adding transactions to it. So there's going to be a slight difference of a couple seconds worth of transactions between the miner who found the block and then the miners who are still looking for the new block, and then they get sent this block by the other miner and now they have to verify it. So if it's only the last few seconds that are different, the reason why this helps is that instead of having all the transactions different and then the whole Merkle tree being changed, you only have a couple differences between the Merkle tree of the block that was sent to you and your own Merkle tree. So it should be less computation and it should be easier for the miner should be easier for the miner to validate the block. And that's what they basically seem to say, is that it's for block propagation that CTOR is better, especially if you're using something like graphene. And just so you guys know, the way graphene works is it uses invertible Bloom lookup tables and Bloom filters. And so it basically checks to see which transactions are different between the set of transactions in the block that was given to you and the set of transactions in the block that the miner already has. And so this all seems to mesh up together. Like I said, I had to just think this through on my own. But yeah, so basically with CTOR, the propagation of blocks becomes vastly less computationally intensive, and that's really the reason for using it. But if you look at some of the critiques of CTOR, there are some critiques that say having a predefined order doesn't necessarily stop you from having to recalculate the entire Merkle tree, and the reason for this could be something very simple. Like if you look at the Merkle tree we have below, if you just add one transaction into it, like let's say your transactions are off by one, your one transaction is going to get put in there in order, and this can throw off each and every single one of the leaves in the Merkle tree. Now, this sort of depends on how you create the Merkle tree, and technically speaking, I think they're moving to using something called a Merklix tree. It's like Merkle tree, but ends with IX instead of just Merkle. So a Merklix tree is what I think Bitcoin Cash is moving towards, and I think this sort of mitigates that problem. But I'm not 100% sure. Like I said, they don't really talk about ordering all that much, but having the predefined order may not necessarily save you so much computation as far as Merkle tree recalculations when blocks are propagated. However, the thing that has to be noted is that when Bitcoin SV did that massive block of a huge number of transactions, um, and it got reorged. It seems like whatever Bitcoin SV is using right now, and it's using TTOR obviously, but obviously their software is not ready for that. And the problem seems to be the Merkle tree. But again, I can't tell you that absolutely for sure. But that's the most computationally intensive part of propagation. Okay, and so the other critique of CTOR is that changing transaction order affects copyleft hash token applications. And the reason why it does this is that if I am the creator of some sort of content, some digital content, like let's just use the board game example that I've always used. I've always said I need artwork, I need graphic artists to help create some of the artwork for my board game. Um, and if I have this contract out there that says, hey, look, I need this and this done, and whoever does it, like you're the one who will, you'll become owner or part owner of the project and of the board game. But if there's no transaction order, the problem that can arise is that let's say somebody uses some website and they try to put in some they create some digital content, some digital artwork for my board game, and then they apply to have that to be used as my board game. Well, if there's no transaction order, or if the transaction order of the blocks is alphanumeric, I can't tell by looking at the blockchain um, if their transaction was the first to reach me. And why this is important is if they're using some sort of website to give their content to me, I guess. If this content simply gets copied by anybody, and that person who copies the content sends their transaction out to the blockchain, um, their transaction will be in the blockchain as well, and it will be the exact same content. And how do I know, as the creator of the board game, which transaction was the first actually to be broadcast, and how do I know who is the actual creator of this content? Okay, I honestly don't have an answer to that. You could, technically speaking, have miners go in and look at their internal data to figure this out, but it'd be much easier to just look at a blockchain and say, hey, this transaction was first, so it was the first one created. That's really simple to do, but with CTOR, this doesn't seem to be possible. Okay, and so again, the problem here is with any centralized site offering copyleft features, it can easily be sybiled, and even if the site itself is not um, sybiled, all a person has to do is look at the content that someone put up, copy that content exactly, and then put up their own transaction. Um, and and there's nothing anybody can do, even using offsite wallet software, because somebody could say, oh, if you're using a centralized site and you're using their wallet feature, even if you have natural transaction ordering, they can just copy your transaction and broadcast it first. Well, with natural transaction ordering, if someone's copying your transaction data for copyleft applications like this, where you're trying to get work completed for somebody. If somebody's copying your stuff and then broadcasting it before they broadcast your transaction, you can just use off-site wallet software and then broadcast your transaction before you send it to the site, and that way you know for a fact that your transaction hits the network first. Okay, and so using natural transaction order seems to be best for copyleft transaction applications. That being said, I still don't have an answer for which ordering is best. CTOR seems to scale better, but this is somewhat debatable. And then even assuming though for CTOR, like let's say I want copyleft apps, you could potentially add transaction timestamps to the Bitcoin transactions because they don't include them as of now. This starts getting sort of really technical. I'm not sure necessarily what the best method would be for this. There might honestly be an easy method for CTOR to, sort of tell you which transactions were first. I just don't know. And in the white papers I've read for CTOR, it says there hasn't yet been an application designed where in the transaction order matters, which is true because the Bitcoin SV devs were like, no matter what I try and do to persuade them, they won't build these applications, which is really fucking weird because if they build these applications should only be able to work on Bitcoin SV rather than Bitcoin Cash, and this would be a big, you know, selling point for them. Hey, we're the only ones who can do these copyleft apps, but they just don't do it. So I don't know. But the final point, either method should be capable of scaling, and even if you wanted copyleft apps on CTOR, you probably could do it. You just have to make some changes to the way Bitcoin transactions are made. However, those changes could, cause slight increases in prices of transactions for users who don't want to use these or don't want to use copyleft transaction apps. So it might be better to have natural transaction ordering, even though CTOR could potentially still accommodate these apps. But again, there's very little information regarding these topics. The devs don't really like to talk about it all that much, and when they do, they talk in a real academic sense, which isn't, there's nothing necessarily wrong with that, but I don't know. It always irritates me that they don't try to talk about this in a way that your average person can understand, because it's not really that complicated of a topic. Obviously, the actual coding and how you implement the coding, that's sort of complicated, and that's for the developers only. But to just talk about the features and what it allows you to do, that's not that terribly complicated. But anyways, I hope this helped to explain transaction ordering for you. Like I said, I have no idea which transaction ordering is best. But I do slightly prefer the natural transaction ordering. Anyways, there will be more videos coming out soon. Hope you enjoyed this one.